Good evening, students. We'll start with the class. In the previous class, we had seen something called a center of mass. Okay. So, any body is there, any body will be always made up of many particles. This will be array. So, any body is there, we have randomly, this is made up of many particles. There will be various masses m1, m2, m3 like that up till mn. Okay, with reference to one, suppose we are taking any one reference at origin, then we saw like this with every particle you can always calculate if these are the distances from a reference point. Okay, so this is always considered as 0, then x1, x2, x3 up till x. The center of mass main x was m1 x1, m2 x2, m3 x3 and so on up till mn upon all the total mass. So instead of writing like this also, sometimes in the textbook or some other book you will come across a sign like this. Now I can always something called as summation sign. If you're adding all the terms, you can just generalize. This is called as a summation sign. Means I'm summing all this, adding all this. So in general, what is the formula? Only these subscripts are changing. If you see, this is 1, this is 2, but that main terms m and x is remaining the same. So I'll just use a general formula m into x. Any letter I can use, up to you all. You can use letter I, you can use letter J, maybe I'll use I. So I can go from, okay, upon summation of total all the m. All the m, instead of summation of m, they use capital letter. M is what? Sum of all masses. Sum of all the mass. They use capital M. This I value can go from 1, 2, 3 up till n. Every time you have to change. Okay. So in general, you can write like this: sum of all the terms from 1 till n. This is center of mass. Sometimes we may see this. This is what this is called as a discrete. Discrete means different particles far away. You can what is that? You can actually locate where they are. Different particles means little far away. But sometimes for a rigid body, this is of discrete. Center of mass of a rigid body. Rigid body means a solid body which has like lot of particles very packed with close to each other. Okay. Then what is a rigid body? Can be treated as continuous distribution of particles. Continuous distribution of mass because particles are densely packed. Densely means very close to each other. So you cannot take them discrete, separate. Discrete means, yeah, best of word is separate. You can take them as separate, but there are some rigid bodies that the particles are so close to each other you cannot even make out what is M1, what is M2. So you have to assume it to be like a continuous. There is no gap only between any particle. This is okay for some gas or like some light object. But if they are closely packed, then you have to take continuous. So in that case, what you have to assume is, now if you are splitting the body into so many particles, very close, okay? I'll try to explain this. You have this box and you have this box. Consider you have only this many particles. Here you have many of them. They might be very heavy ones. Okay, whatever it is, suppose this is 1 kg. This is also overall maybe 1 kg. Okay, maybe this is bigger also, doesn't matter. We don't. Now you know that for it to make 1 kg, this will be very small. Maybe only 10 of them, like 10 grams or 100 grams each will make 1 kg. But what will happen? More the particles, as the number of particles increase, the mass of each particle will reduce. More the number of particles, mass of every particle will be small. Okay. So for continuous distribution, like this, very close to each other, mass is very small. So what will be x? X will be, so we can take it as delta m, or you can use it as dm. You can use delta m, you can see. So what will the formula look like? Okay, now here you cannot use a normal summation sign. This sign is always for discrete. Okay, but for continuous, we use an integral sign. So this particle, this thing is like distributed into small parts. So this formula may be for a small part, like that for entire thing. If you want to join, okay, add all the masses, this part, okay, then we have to use for continuous, you have to use an integral sign. So delta m can be taken as dm. Okay, then that there will be no I, because it's continuous, it is taken. You cannot distinguish whether it is particle 1, particle 2, particle 3. So in general, it will be x into dm upon m. M anyways, we can keep it out. This is the formula for continuous distribution. This is why we use dm instead of m, because mass is very small for continuous. Same way y will be yd. In case you want to use z, z will be 1 by m. So for continuous, instead of summation sign, it is the integral sign. And instead of delta m, instead of normal m, it is dm, because the mass is very small for continuous particles. For continuous, we use integral symbol. This is a summation symbol, this is an integration symbol for continuous. Center of mass of homogeneous bodies. What is a homogeneous body? Homogeneous means they are all like any body which will have uniform distribution of mass. Suddenly it will not be like here there is a lot of mass, here it is vacant. Not like that. It should not be hollow at some place, it should not be hollow, thick at some place, not like that. Homogeneous are with uniform distribution of mass. Anywhere you any piece of that body you take, it will have that much mass only. Uniform, equal, that means equal mass distribution at each point. You can put this bracket like this. Each part of the body, I can say mass at each part, okay? Mass at each part of the body remains same. Anywhere, any part of the body you take, it should always give that much mass compared to another part. Those are called as homogeneous ones. Mostly like symmetrical objects. If you consider a sphere, suppose a sphere will have uniform distribution of mass everywhere in general. So where does all this now, like circle, like square, mostly they will always lie at the center. Where does the common, if you calculate, center of mass will always be at the center on, because everywhere equal distribution. If somewhere this side it was heavy, then what would happen? Then this will shift to the heavier side. Okay, so whenever you have equal distribution of this for homogeneous, center of mass for homogeneous, it's understood of homogeneous we are talking, and it lie at the geometric center. For example, for a sphere or a circle, you can consider a sphere which is of radius r. R is nothing but the distance now. I want to see what is the center of mass. Consider this point to be r. Center of mass is at R. Now I'm considering a homogeneous rigid body. So its continuous symbol will be there. This is the formula 1 by m. Okay, this we know already. Formula x is what? I just use this formula first so that you know how it ended up. X dm. Now instead of x, what is the distance here? R from the outer part till this. So it will be smaller. So the main center I'm taking as R. So R will be 1 by m. Okay, for like a homogeneous body, this will be at the center. And if center lies at the origin, imagine if this is at origin 0, 0. Then R will be 0. Because R is at 0. If this center lies at the origin 0, 0, you are taking this as the reference, then it will be R will be 0. In that case, this is R is 0. R will become 0. So M will go up here, that will also is 0. So total center of mass when it lies at the origin, what is that at the center, as well as if the point is at 0 exactly at the origin, then the center of mass will be 0. So remember, center of mass of a homogeneous body always lies at its center, and if the center is at origin, then the center of mass will be 0. If this is at the center and if it lies at the origin, then it will be 0. It could lie somewhere else also. Huh? It could lie at some other point, suppose 1 comma 2 and 1, then it will not be 0. Then it will be x part will be 1, y part would be 2. That this is only explained for origin. Next is motion of center of mass. So center of mass is nothing but what you are just imagining that whole big body as one point. Now this whole sphere as though it is crushed, okay, or crumpled and concentrated over here. The center of mass, whenever you calculate, it means the whole body is concentrated. Means it is just like brought together as one small point towards its center. So if you are calculating, suppose if the body was moving here, what happens if this sphere is moving? Now we are assuming that every single particle is in motion. Every single. You cannot keep calculating all the velocities. It's very difficult to calculate every single velocity. So what we do better, just assume this whole sphere as just one point is moving. So I'm generalizing it to just one point, this whole thing, crushing it to one point, then moving. So it becomes easier, no? Straight away. So any body, whenever we say, well, it is moving at velocity v, it means we are telling it respect to the center of mass, not the front part of the car or the back part of the car, the center of the car, the center of mass. So with reference to one single point. Now we'll see what is motion of center of mass. So basically it means center of mass means we are calculating motion of all the system of particles in general. Okay, basically we are generalizing all the particles are like moving at this with reference to this center of mass. So which are the two things which we have need to calculate, which can tell how fast it is moving, how slow it is moving? It decided by motion of center of mass includes two things: velocity and acceleration. So now we'll see what is the velocity of center of mass and what is acceleration of center of mass. V1 maybe we'll just consider two particles just for reference. V1 and V2. This one's mass. Okay, M1 and M2 will take two particles. Now this is moving. But just to make things simple, I'm just considering this body is made up of only two particles. Okay, just assuming maybe these were the two particles. Now this body is moving. Now obviously this particle must be moving at a different velocity because it is at a different place. Because it's a rotational motion now. So this must be going up and this must be coming down. Okay, this is moving. So obviously this one's velocity will not be same as this. So this is V2 considered. Now like that we cannot sit and tell every particle. So what I'm doing, I'm trying to generalize with respect to center of mass maybe. I'm just assuming it here. To center the main velocity would be center of mass. Okay, either sometimes you may this center of mass or you may come across just directly cm also, both mean the same. Center of mass will be same way how we had used for distance, m1 v1. Now instead of x1 it will be v1 because it is velocity average. If you have more particles, this is for two particles. N particles, m1 v1, m2 v2, m3 v3. Like this, if we do the same thing for n number of particles, okay, this will be the velocity formula for every single particle. And then this will be main center. Average of all this will give you the main velocity. Like in general, combination of all the particle velocity will be concentrated to one single velocity. In general, I told you this is now for discrete. Whenever we use this formula, this is 100% for discrete. Discrete means they are separate particles. We can count those particles. So there are n number of particles. So we'll use a summation sign. M1 V1 is MIVI upon a capital M. Total mass is M of the whole body. You add all the masses. So this is velocity of center of mass. This what we did is for velocity. Now same way we'll see that for acceleration. Same thing, you just have to change the letter V to A. Now second one is for acceleration. So now we'll consider if m1 is moving with acceleration a1, this will have a different acceleration a2. So in average acceleration of common center acceleration will be even if you don't write cm, no, capital A is understood. This is all A now instead of V. That's the only difference. That is for acceleration. This is for two particles. If this is moving at one velocity, this is average acceleration will be this middle between the common point between both the acceleration. Same way, there are n number of this, then this will be the formula. So this is generalized to a summation sign. Means I've added all where I is from 1 to n. I have to start from 1 and then end at n. Now, based on this acceleration, we see what is the force formula. So we'll just check for force now. So what will be a main center of this total mass will be? We have just seen this formula. What is that? V of Cm was what? M1 V1, M2 V2, M3 V3 up till Mn Vn upon n. Velocity for n number of particles. Just now we had done that. So we are trying to check what happens in terms of force now. Different quantities for center of mass. Now this m, I will just take this side up. So I will just avoid writing this cm. Okay, I can write also, no problem. M, I'll take it up. So this will be m1 v1, m2 v2, m3 v3 plus mn vn. Now I want to express this in terms of force. So force will be coming into picture only when there's an acceleration, because we know that force is mass into acceleration. Mass is there, but I want to convert this in terms of acceleration. This value. M is there. But how to make this? We know that acceleration is always change in velocity upon time. So I'll take derivative, differentiate on both sides with respect to t. So every way I just take the derivative of this. Mass is always constant, so it will come out of the, just write d by dt everywhere. Taking derivative means just adding d by dt there. There's this one dot dot dot. Just put that because in generalized it is. Now you know that change a is always change in velocity upon time. Everything will be change in velocity time is acceleration. This also will be acceleration. And you know that force is nothing but mass into acceleration. Mass into acceleration is nothing but force. This is center of force. All the forces we need to add. So this is nothing but like a external force. So what is this external force in general? We can put out this because it's a vector quantity. Force is always a vector. It matters which direction you apply in. The force formula is mass into acceleration, where this is center of mass force, like 1 point concentrated. Acceleration also, after taking average of all the particles, whatever you get is that. So what you can conclude from all this is nothing but you can consider center of mass of all the system of particles, or center of mass of a system of particles moves as if all the mass of the system was concentrated and all external forces were applied on that. Same thing which I've been repeating again and again. So what it means is all these particles whichever were distributed, they are like equivalent. All these particles which were far away, like they are brought together and made it into small compact particles. It's compressed into one small point, concentrated at one point, and all the forces from every single mass is like acting on that particle to bring it together. So there are so many external forces which are trying to bring all the particles to one center. Next is the linear momentum. So whatever formulas we had studied in the previous chapter, no, same thing it is. Only we have to write center of mass. What is linear momentum? We have studied in the chapter. Linear momentum is nothing but we use the letter P is always product of mass into velocity. This is a fixed formula for linear momentum. We don't use L here because L is always going to confuse you with the length. We use the letter P for linear momentum. If you use L, you might think it is length. So that's why it is a different letter P. So this is the formula for linear momentum. Now if you have for a system of n number of particles, total P will be P1, total number of particles will be P3 plus P4 up till Pn. So total P in terms of mass will be that will be if you want to use you can what is P? Nothing but M1 V1, M2 V2, M3 V3 till Mn. P is nothing but M into V. Total number of particles P will be all summation of all. So instead of P, I'm just putting this. Velocity of center of mass we have just seen. What is velocity of center of mass? Summation of mi vi upon cap total m. So just cross multiply this and see. The summation sign. What is m into v? Nothing but p. Okay. Same thing it is. Summation is this full thing. So total m into v. So this is only. So basically, actually, no one will ask you the derivation, but I'm just trying to tell you how it is formed. So its whole system is like this. It's using v from the previous velocity into mass. In general, we are trying to calculate. So basically, what you have to know is finally center of mass is always nothing but mass. This is your total mass So whatever formula you know, you just have to replace it by center of mass now. In the previous chapters, now whichever formula we have studied, now we have to try to think it. Maybe whatever we were doing, that was for center of mass point of view. Okay, whenever you have many, so it was not in general of the whole body, it was of the center of mass. The same thing which we had studied again, Newton's second law. As per Newton's second law, what it said was dp upon dt was equals to force. Now again the same thing. This is center of mass. This is external force which is applied towards the center. So any linear momentum we have just seen, like basically all the external forces concentrated at one particular point. So if you are using linear momentum for center of mass, so all the external forces are concentrated towards the center of mass. This is the general formula from previous chapters which we know. Now we are just applying it in terms of center of mass. Next is the vector product. Vector product was already done in motion in a plane chapter, but again they have introduced here also. But why we need to study this vector product is, why vector product? Why we need to study this is because all these quantities which we'll be studying in this chapter, quantities in rotational motion, which we will come across next. Under rotational motion, we'll make use of this vector product. That's why we need to study what is vector product. So which all things like torque will come across, we'll study in detail. And what is angular velocity. Okay, so all this will make use of vector product. Also now we'll study in detail what is vector product. Vector product is also called as a cross product. Before that we have studied a dot product. Okay, wait, first I'll tell, although it's not there in this chapter, I must have forgotten also. I'll just tell what was dot product. There are two products. One is always called as a dot product or called as a scalar product. So if vectors, there are A and vector B, the dot product is always given as a dot. And the formula is always A magnitude of A magnitude of B cos theta. And for vector product, if you have the same vectors, then the answer is A cross B is given as sine theta into n cap. Now this I'll explain in detail. Right now we don't have the dot product here. Only one problem I'll solve based on this. What we need is main is the vector product. So what is this vector product? Now consider this is a flat surface. Now suppose, okay, now there's one line here. This is one edge. Consider this one edge of the book is this pen I'm holding like this is vector A, and from this corner it is vector B. Okay, so these are meeting at the corner of the page at 90 degree. Just take the edges. One is vector A, the other one is vector B. Okay, so these two are at 90 degree or any other angle also, any line also. It may be this, but in the same plane. Two pens you consider like this. So whichever side it may be, but they are on the same page. Now I want to find cross product of these two. The cross product is always perpendicular to this page. So that will be A cross B. Okay. So this is the these are the two vectors in the plane on the page. Then the vector product is always given as A bar cross B. Okay. So this can be written as C bar. So C bar will be always A bar cross B bar. And the formula is always A bar, B bar. Now which is the vector? Any vector we have to take as n cap. This is called as a unit vector. Sine theta, okay, A bar cross B bar into n cap. This is the main formula. If you try to take magnitude of this, this is what normal vector. Okay, magnitude means always a pure number. So if you want to take a pure number, then you have to replace this by this sign. So magnitude, when you take this unit vector, magnitude is always equals to 1. So you will get this value will become 1. So this n will go. So if you replace this by magnitude, the answer will be just this much. To understand the difference, this is a vector and this is a pure number. This will be in terms of I, J, and K, and this will be normal pure number. You consider again the fingers otherwise. Okay, these fingers. So A and B, the middle finger and the pointing finger are like A and B. Okay, just consider like this. You are not able to see. So what is going to happen is the thumb will be pointing upwards. So that is your vector C. Now if you try to do this ulta B cross A, okay, B cross A, always the thumb will be downwards. Ulta. One time, suppose if your middle finger is pointing towards you, if you reverse the thumb downwards, the middle finger will be pointing outwards. So B cross A will be always equals to ulta. Minus n cap. This way. Suppose this is B bar, this is A bar. This is in the downward direction. This will be B bar cross A bar. So A bar cross B bar is always equals to minus B bar cross A. Just put these arrows. I'm used to this, just putting these lines. So over here, thumb will be upwards. Just try, okay? Your thumb, this is the right hand rule. Huh? So here, thumb will be upward. Your thumb will be downward. So we'll see what are the properties of vector product. First one is, it is not commutative. Not commutative means what? A into B should be same as B into A. But you know that A cross B is not equal to B cross A because it is minus. Minus 5 cannot be equal to plus 5. Okay, A cross B is equals to plus C and B cross A is equals to minus. This is first property. Magnitude is same. Huh? Value, if you try to take, when you take magnitude, then it will be same because magnitude of negative also will get positive one. Magnitude is nothing but like taking a modulus sign. So magnitude is same, direction is different. So this is the first property. Second one is distributive law. If you have any vector outside, you can always distribute. This you can apply to this one also, this you can apply to this one. Only thing you cannot change this order. A will always come first, B will be next. You cannot write C cross A suddenly. Third one, no change on the reflection. Means what? Suppose if A bar, you are making ulta direction minus A bar, and B bar, you are making minus B bar. Both the vectors are changing, then it will not make any difference. A bar cross B bar will be same as minus A bar cross minus B bar. 5 minus into minus will give me plus 1. So if both the vectors I am reversing, means taking the reflection, so it will not make any changes. Overall, both vectors I am changing the direction, So minus into minus will anyways give me plus. Next is vector product of unit vectors. Wait, x, y, and z you can take. X-axis, y-axis, and z-axis. Along every axis, no, there is always a unit vector. So along x-axis, the unit vector is I cap. Along y-axis, the unit vector is j cap, and along z-axis, the unit vector is k cap. What does this unit means? Value is 1. So their magnitudes are always 1. Of all these three vectors, no, their value, if you take the magnitude, it is always 1. That is the speciality of unit vectors. So they are the standard unit vectors which are fixed. Along x-axis, it will be always I cap. Cap y, not bar like this arrow. Arrow means a big vector. Unit means its magnitude is 1, then we put a cap like this. So we'll try to take cross product of them. Cross product with itself we'll try first. So we'll just apply the formula. So magnitude of I cap, magnitude of I cap, okay, into sine theta. Now what is the angle between them? Always 90 degrees. So straight away sine 90 is 0. So straight away answer will be 0. Same way you try with j cap. Theta is nothing but always angle between the vectors. So if you want to check, all these are always 90-degree different from each other. You can take the corner of your wall and see. So the two ground lines and the top line. Same way j cross j. Now this is 90 degree. Sorry, this is 0 with itself. Any vector. Sine 0 is 0. This I am trying with itself. If it was j, then it would be this. With itself, no? Any vector with itself, angle between them is always 0. Always take 0 degree. So j cap dot j will be again sine of 0. So that will be same way k cross k also will be 0. So with itself, the cross product always will be 0. Now we'll see with others. I'll see what is I cross j. So what is the vector product? A bar cross B bar will be A bar B bar sine theta into n cap. This is always the perpendicular vector. Whenever I drawn this diagram, no, A bar cross B bar, what was this? I told you n cap is always perpendicular to this. The unit vector which is always perpendicular to these two vectors. So sine theta into n cap. As of now, I'm writing it as n cap. Now, what is the angle between I and J? It is 90 degree. And magnitude of I is 1. Magnitude of J is also 1 because they are unit vector. Sine 90. Now, which is the vector which is perpendicular to these two vectors? If you see, it's a perpendicular vector. A vector which is perpendicular to I and J is nothing but K. So I write this as K. So 1, 1, sine 90 is 1. So this is K. So I cross J will be equals to K. Same way you can try J cross K will be equals to I. And K cross I will be equals to. Now if you reverse the direction, what is going to happen is A cross B is this, no? Then what will be J cross I? That will be minus. Why A cross B is C and B cross A is minus C. Same way J cross K is I, then K cross J will be minus I. Yeah, if I take I cross K will be minus. In that previous chapter also I told you to remember this diagram. I, J, K. Always you have to move in this direction clockwise. I cross J will be always equals to the next one. If you are going in the same direction, it will be plus. You are going in the same direction which is been told. So I cross J will be equals to the third fellow. J cross K is I. So J cross K will be equals to third fellow. Now K cross I. This into this will be equals to third. As long as you are going in the same direction, it's all positive. Now look at this. J cross I. You cannot keep anyone in the middle. Huh? Just because they have given it J cross I, you cannot jump over this and go to I. The shortest distance you have to take. Now what is happening? J cross I means you are traveling this side. Ulta for J cross I. So you are going against the direction of this. So if you had gone ulta, it will be equal to third fellow, but it will be minus. Same thing works for this one. Now K cross I want. K cross J. So I cannot come this way. Oh, I told you again, you cannot cross a different variable. So you have to take the shortest distance. Shortest distance from K to J is this one. So what is going to happen? You are coming ulta from this, going anti-clockwise. So it will be minus. So this is how just one simple can tell you all the formula. So I cross J will be equals to K. K cross I will be equals to J. Okay. And J cross K will be equals to I. In the same direction. All positive, ulta means negative. Mathematical form of cross product. What is actually A cross B when you go to calculate? Something will be given in terms of I, J and K, then how to calculate that? So A bar will be what? Suppose given to you as AX, I cap, and B bar is given to you as BX, I cap, BY, J cap, then A cross B will always be equals to, you have to put it in the determinant form, something you will try to remember from motion in the plane chapter. I had explained to you all this. This will always be fixed I, J, K. Then this you have to put AX, ay, az, bx. Only the coefficient you have to put. If something is missing, you have to put 0. So this is how you have to find a cross product or the vector product. How to solve the determinant? You have to always write I cap, close the column, close the row. Whatever is left, you write here. Middle sign will all next. You are done with this. You have to move on to the next element, that is j. But middle, you have to always keep this minus. Always negative, middle one. J will always be negative. Now take j, close the row of j and close the column of j. What is left? You write. Maybe you have to write it k. Close ax, ay. K will be this, you have to close. And how to solve a determinant? Always you have to cross multiply. From here to here, this always element you have to take first. This into this minus this into ay, bz. Middle sign is always minus. And then az, b. Minus j cap. Everywhere cross multiply. Minus ay, bz. This is how we have to solve. So just one problem I'll solve and then end the class. So the two vectors given are find dot product or scalar product. Second, cross product or vector. Whenever you have to find dot product, you have to use dot in between. This will be 3 I cap. Just substitute a bar. Dot. Just put b bar. And how to solve this is always I you have to multiply with I coefficient. J you have to multiply with J coefficient. K you have to multiply with K. Don't have to multiply I, only the coefficient. So 3 into minus 2, middle sign always plus. What is this? Minus 4 into what is coefficient of J? 1. Then 5 into minus 3. And then just solve. You can get negative answer, no problem. Minus 25, no? So this is dot product. Now we'll see cross product. I've given both so that you understand what is the difference. You see, you get a pure number. That's why it is called scalar. Scalar means constant. You will not get an answer in terms of I, j, and k. But this one, vector product, you'll always get in terms of I, j, and k. So as per the formula, you have to put I, j, k. Put only the coefficient now. 3, minus 4, 5. Minus 2, 1, minus. Now put I, close the row, close column and row. What is left you put. Middle, I told you, is always minus j. Close this row and column. This row, column and the row. What remains is this. 3 minus 2, 5 minus, then k cap 3 minus. Now we need to cross multiply. Minus 4 into minus 3. Middle sign is always minus. 5 into 1. Then minus j. 3 into minus 3. Middle sign is always minus. Then 5 into minus 2. And then k times 3 into 1 minus minus 4 into minus 2. Now solve. This will be 12. Minus into minus is plus 12. Middle sign is minus 5. Then plus 3 into minus 3 is minus 9. Minus into minus is plus. 3. Minus into minus is plus, into minus is overall minus. 7 I cap. 7 into I, 7 I cap. 1 j cap. This is A cross B, the vector. We got a vector back. So that's why it is called as a vector product. If you are asked to find B cross A, you just have to reverse the sign. In case you are asked to find magnitude, although it was not in the question, what you have to do is just take coefficients square. It's x square plus y square plus z square. You just have to square the coefficient. 7 square minus 1 square. Even if you don't take minus, it's fine because after squaring, anyways, you'll get plus. Coefficient of k is y. Yeah. 49 plus 1 plus 25. So root 75 units. So that is called as, no, not units, just leave it that much also, no problem. Only if it is length and all, you can write as units. Otherwise, magnitude is root 75. Okay, so this is about cross product. I'll stop here.